In this video, we're going to be looking at multiplying decimals. Multiplying decimals is identical to multiplying whole numbers with one exception. You've got to ignore the decimal point and treat it like it's a whole number. And then you've got to put the decimal point back in the answer. If you forget to put the decimal point back in the answer, you're going to get it wrong. But it's pretty easy to know where to put it through two different methods. One is rounding, so you can kind of figure out where it goes just by rounding the decimals and kind of seeing where it would go. The other is counting the number of decimals in the question, or the number of digits after the decimal in the question, and then having the same in the answer. So that might sound a little confusing, so let's take a look at an example here. 3.7 times 5. I'm going to treat it like it is 37 times 5, right? Like I would line, I don't line them up, I just put the digits underneath each other, right? Like the 5 would go under the 7. I don't line up place value. If I lined up place value in the original question, that 5 would be under the 3. So I'm not doing that. I'm going to treat it like it's 37 times 5, okay? So in 37 times 5, you do 5 times 7, 35. And then you do 5 times 3, which is 15, plus the 3, 18. Now, if it was 37 times 5, the answer would be 185. But it's not. It's 3.7 times 5. So I've got to put my decimal point back in the answer. So as I said, there's two ways to do it. One is rounding. Now, if I round 3.7, I'd probably round it to the nearest 1. It'll be 4, right? And 4 times 5 is 20. So where's the only place down here in the 185 where I can put a decimal point that will make it close to 20? Well, it's got to go there, right? That's the only place I can logically put that decimal point. If I put the decimal point here, that's not close to 20, 185. If I put the decimal point here, 1.85, that's not close to 20, or here. The only place where it's close to 20 is there, so logically that's where it's going to be. Now the other way to do it, and this is perhaps the easier of the two, is how many numbers are after the decimal point in the question? Well, in 3.7, I've got one digit after the decimal point, and in 5, I don't have any. The decimal point, remember, is at the end. There's nothing after it. So I have one digit after the decimal point in the question, so I'm going to have one digit after the decimal point in the answer. And that always works, okay? So let's take a look at another one. This time we have 3.7 times 5.2. So I've got two decimals being multiplied here together. So I'm going to treat it like it's 37 times 52. So I'm going to ignore the decimal point. So I don't line up the decimal point necessarily. It just happened to line up this time. This time it didn't, obviously, because decimal point actually goes there. So you don't line up the decimal points like you do with adding and subtracting. You ignore them. Pretend they're not there. So I'm thinking 37 times 52. Okay, and if you want to write out 37 times 52 and just do it as a regular, without them, and come up to your answer that way, it's perfectly legitimate to do that if having the decimal points in there confuses you. But there we are. 37 times 52. 2 times 7, 14. 2 times 3 is 6. Plus the 1, 7. Add a 0 here. 5 times 7 is 35. So 5 and the 3. And 5 times 3 is 15, plus the 3 is 18. Alright, let's figure out what that is. So that'd be 4, 12, 9, 1. Okay, so again, where's the decimal point go in the answer? Because if it was 37 times 52, it would be 1,924. But it's not. It's 3.7 times 5.2. So again, I could round it. That could become a 4, the 3.7. 5.2 could become a 5. 4 times 5 is 20. So logically, the only place that it can go to have it anywhere near 20 is here, right? 19.24. But the other way is how many digits are after the decimal point. Well, in 3.7, I've got one digit after the decimal point. And in 5.2, I also have one digit. So that's a total of 2 digits after the decimal point. So I'll want to have 2 digits after the decimal point in my answer. So that's the other way of figuring it out. Okay, let's do one more. 99.2 times 0.85. Again, I've not lined up the decimal point, I've lined up digits. I'm going to treat it like 992 times 85. Okay, so we'll go ahead and do 5 times 2 is 10. 5 times 9 is 45, plus 1 is 46. And 5 times 9 is 45, plus 4 is 49. Okay, I'm starting with the 8s now, so I'll put a 0 there. 8 times 2 is 16. 8 times 9 is 72, plus 1 is 73. And 8 times 9 is 72, plus 9 is 81. Add those together, 0, 12, 13, 6, 8. Okay, so if it was 992 times 85, it would be 86,320, but it's not. So again, I could round to 100 times 1. That doesn't really help me in this case. So let's take a look at the number of digits we have. I've got 1, 2, 3 digits after the decimal point in the question. 1 in the 99.2 and 2 in the 0.85. So I'm going to have 1, 2, 3 in the answer. So my decimal point will need to be here. And since when I round 99.2 to 100 and 0.85 to 1, 100 times 1 is 100, 86 is the closest I can get to 100. So it just makes sense. So that's how you do it. You ignore the decimal point, you treat it like a whole number, and then you put the decimal point back in the answer, either by rounding or by counting the digits after the decimal point in the question, making sure you have the same number of digits after your decimal point in the answer.